As a writer, words are very important, and being deceptive with words can have a huge propaganda influence. The industry, by labeling something that is rather toxic in an innocent frame, can make people just fall asleep and not think that that's a problem. That's what they've been able to do.
Welcome. I'm Dale Walkinen.
And I'm Tina Curran, and this is Facing Future.
Our guest today is author and researcher Justin Nobel, whose work exposes serious problems with radioactive waste from oil and gas operations. This sludge or brine is both toxic and radioactive, yet the industry, with the blessing of our government, labels it non-hazardous waste and transports it all over the country. It seeps into the water table, it's in the rivers, it's used in road de-icing salt, and it's spread on grazing land.
Cancer clusters are directly related to filled-in dump sites that will remain radioactive for billions of years. Injection wells and sludge sites are covered up and used for housing, markets, schools, and the manufacture of consumer products. It's infiltrated our lives, as Justin Nobel exposes in his deeply disturbing book, Petroleum 238. Welcome, Justin. Thanks for joining us today.
Thank you so much, Dale and Tina. Really an honor to be here. It's an exciting program to be on, so thank you.
Oh, we're excited to have you. This is such important stuff, and nobody's talking about it but you, as far as I know. How worried should we be about this crazy, careless disposal of radioactive waste?
I think you laid it out very well in your introduction. I see the waste brought to the surface in oil and gas development as really the primary problem that this industry faces, and something that really hits home and smacks against the wall of human health well before climate change and climate emissions, which of course are massively significant problems that the industry has a responsibility for. But this is their first problem. So you can't bring oil and gas to the surface without bringing up a wide array of materials from deep underground. These are naturally occurring materials, but it just so happens that they contain some of the more toxic and dangerous contaminants known to planet Earth. And that includes very interesting radioactive elements. The processes of oil and gas development can further concentrate those contaminants and concentrate the radioactivity. And unfortunately, the industry has never developed a good solution on how to deal with these different waste streams. So they've been spread, spilled, spit out, sloshed around, emitted, and in general, released and disposed in a manner that's entirely inappropriate. And because the industry is so overburdened with this waste, they've tried these really devious tricks, which you mentioned in the introduction, and literally tried to transform this waste into consumer products. And that's a trend that under the new administration continues at a heightened and even less regulated pace. So it's a big concern, and it's now an even greater concern in this era of complete rollback of scientific logic.
Well, I have a quote from the American Petroleum Institute, which says, "Any attempt to remove radioactivity transforms it from a dilute source into a concentrated one. Radioactivity cannot be made inert by chemical means." Whoa, what can be done with it? They're putting it in injection wells, apparently, but these are leaking. And what in the world can we do instead?
Well, first, I'll give you all an idea of how much waste the industry is dealing with, because I think that's really important to understand. So one of the primary waste streams the industry must contend with is a very salty fluid that they refer to rather innocently as brine or produced water or just salt water. In some parts of the country, they simply say water. It's not water. It's not just salt water. And brine is a word that makes you think of food. It makes you think of like a holiday meal or someone's jarred pickles. And it's really completely deranged that the industry is allowed to get away with this. You know, as a writer, words are very important. And being deceptive with words can have a huge propaganda influence. You know, the industry, by labeling something that is rather toxic in an innocent frame, can make people just fall asleep and not think that that's a problem. And that's what they've been able to do. But brine, not only can it just have elevated levels of salt, it can have toxic levels of salt. The salt alone is highly problematic. Brine is also rich in volatile organics. So these include known human carcinogens like benzene. Um, Benzene is around gas stations, it's around refineries. It has this kind of sometimes almost seductive, sugary smell, but it's a human carcinogen. And brine is there, benzene is there in the brine. And then you also have elevated levels of heavy metals like lead, strontium, arsenic, very dangerous and toxic heavy metals to humans. And then you also have elevated levels of radium, which is a radioactive heavy metal. So the word brine, inappropriate. It's got all this toxic stuff, and the word brine hides that. So each day across America, 3 billion gallons of brine is brought to the surface. And again, the more appropriate word would be toxic radioactive oil field waste. 3 billion gallons a day, that's 1 trillion gallons a year. If put into your standard oil barrel, that 1 trillion gallons a year of oil field wastewater, if you put it into your standard barrel, which is like waist high, and you stack them atop one another, you would reach the moon and back 28 times.
With 1 year's.
1 year's worth of waste. So that's an incredible waste stream, and the industry does not want it. They want the oil, they want the gas, they want what's referred to as natural gas liquids, which would include things like ethane and butane, propane. They don't want this waste. And so right there, you start to understand the industry's conundrum, which is to mislead, to misidentify, to misinform, and to just get the hell rid of this stuff as quick and easy and cheaply as you can without truly considering its constituents.
You talk about what the accepted level of radiation is for radium. It's 5 picocuries per liter of water. But what is the radium that's coming out of these wells in terms of its radioactivity?
Yeah. So you ask about radium, which is really one of the most important and concerning contaminants in brine. EPA knows a good bit about radium. We know a good bit about radium as a society, and much of that goes back to the story of the Radium Girls, largely women, but men too, who were working in factories in the early 20th century and doing this, very interesting job of using a radioactive paint and sticking these tiny little paintbrushes in it and applying it to the surface of watches and clocks, and it would cause them to glow. Radium excited zinc molecules in the paint, and the paint would glow. And how exciting, because then you have a glowing watch or clock hand, and you can see the time in the dark, right? But if you've done fine painting, you take the little brush and you dip it into the paint, and then you paint the clock, and then you dip it into the paint again, and then you paint the item, and the tip can get dry very easily, so then you stick the tip of the brush in your mouth to keep it firm. And over time, that's exactly what these women did, and they ingested appreciable amounts of the paint, even though it was tiny, tiny amounts, but ingested radium. And radium is regarded by the medical community as a bone seeker. Radium is in the same column of the periodic table as calcium. That just means the outside of calcium looks and chemically speaking acts a good bit like the outside of radium, and calcium, of course, ends up in the bones, and some radium is going to end up in the bones too, and that's an absolutely terrible place for a radioactive element to be, because radium is going to do what radioactive elements do. It's going to blast off a little piece of itself. That's what we call radiation. And you don't want to be near it when that happens. And the bones are very vulnerable to radiation, and especially the marrow and some of the blood-forming parts of the bones. So these women had harbored this very dangerous internal radioactive source, which would remain radioactive over many decay cycles. And they developed cancers, and many of them died. And it was a medical examiner in Newark, New Jersey, who was really able to put together the picture of what was happening. The industry defended their paint. They said it's not causing cancer. This has nothing to do with the radium-laced paint, and focused on lifestyle. And I bring it up because we hear these same things today with people who are often, put at risk from industrial exposures. Because they don't eat right, and they smoke too many cigarettes or whatnot, whatever the excuse is. But Dr. Martland, following the pathways of science, found out that their bones were indeed chock full of radium, because he was able to do autopsies after they died. And he also found out that these women had essentially become human radioactive chimneys, because the radium decayed to radon. Radon is a gas and acts very differently than radium, which is a metal, and a gas wants to escape. And so some of this radon would actually escape out through their exhaled breath. And Dr. Martland was able to measure that and measure the charged air that they were breathing out. And again, this became really indisputable scientific proof that they had radioactivity inside of them. And he traced it back.
I remember from your book, it seems like the governments in so many states have literally defined this brine, this that reaches to the moon and back every year, as non-hazardous waste in perpetuity. It's not something that gets settled again every year. It's just been defined that way. Am I correct on that? Or can you talk more about that?
Well, first we'll focus on the radioactivity component. So because of stories like the Radium Girls, we know that radium can kill humans. So we have limits now. The EPA limit for radium in drinking water is 5 picocuries per liter. You don't need a lot of radium to make water unfit for drinking. 60 picocuries per liter, and EPA actually defines that a liquid with more than 60 picocuries per liter radium as radioactive waste. And this becomes a very important threshold, because when you're writing about this radioactivity, a big question is like, well, how much of it, and is it a dangerous amount? Well, at above 60, we can legitimately say under EPA's guidelines that it's radioactive waste. That's at 60. Now, in the Marcellus Utica, it's the most booming gas formation in the country, and we know that the radium levels in brine in the Marcellus, according to Pennsylvania's Department of Environmental Protection's own numbers, can average 9,330 picocuries per liter and be as high as 28,500. So again, we have 5 as the drinking water limit. At 60, we can call it radioactive waste. And here in the Marcellus, it can average 9,330, be as high as 28,500. And I actually just heard a presentation laying out new research where they found radium levels as high as 42,000 in the Marcellus. So we are well above those thresholds.
Can I just clarify, Justin, is that the waste that's pulled up with the oil and gas at the Marcellus, or is that in the ground, or is that the...
Yeah, so again, we're just talking about the brine. The industry has labeled this really copious fluid, which comes up at all oil and gas wells, brine. So we'll stick with their name for a moment, but brine is filled with salt, heavy metals, benzene, and excessive amounts of radium. And again, that's 28 lines of barrels to the moon and back. There's a lot of brine. Many wells produce more brine than they do oil and gas. So they're really brine producing wells, and oil and gas is often the byproduct, although for us it's the more important byproduct. But the brine generated is copious. So you think, if you stand at a well and look at it, oh, that's oil and gas coming to the surface. Well, sure, it is, but there's also going to be a good amount of brine. And if you look at the wellhead, if it's an oil producing well, you'll see a tank for oil, and you'll also see 1 or more tanks for brine. So the brine is virtually always there, and the brine in the Marcellus can contain these highly elevated levels of radium, enough to legitimately define it as radioactive waste. Now, you will rarely ever see a truck marked with a radioactivity placard. Across the Marcellus, this brine is carried in trucks that look just like ordinary septic trucks, and it will not have a placard or a little diamond-shaped marker to indicate that the contents are radioactive. It will also not have a placard to indicate that the contents are hazardous, and this goes back to your question, Tina, and what's referred to as the oil and gas hazardous waste exemption. And we can get into that because it's a fascinating one too.
Justin, I found as researching this, there's something called the Well Finder, which is a free, publicly available application that you can use to find how radioactive the injection well in your area is. Are you familiar with that?
No, that sounds interesting. I'll look it up now, but I've never heard of that.
One of the most disturbing things that I found was that it's spread on grazing land and crops, so that radioactivity not only does it harm the animals who are close to it, but I wondered how much that's getting into the food that people eat, whether it's meat or even vegetables. Is that radioactivity transferring to human consumption?
Well, this is a great question, Dale, and unfortunately, we don't know the answer because there has not been good science on this. And in fact, states that use this practice, which you're referring to, which the industry calls it land spreading, and it's the spreading of oil and gas waste directly on to cropland and farmland. Now, and that's of course seems absolutely insane. It seems like something out of a Twilight Zone episode, but it is real. And it again traces back to this dilemma that the industry faces of having way too much waste, not really having an appropriate solution for it, and taking these really devious shortcuts in which they can, with sometimes the magical twist of legislation or the regulatory system, change the name of waste into the name commercial product or reuse or reusable product or beneficial use. There's a number of ways that industry can paint a waste stream as something beneficial. And that's very valuable for industry because then you don't have a problem anymore. You have something that's actually, at least on paper, a good. It's a use. It's a commercial product. Now, that doesn't mean that that thing is safe, or it doesn't mean it makes scientifically logical sense. But what it does mean is the industry has successfully found a way to get it the hell away from them.
Could you tell us some of those products? What kind of products are filled with this stuff?
Well, right. Oklahoma is a good example. And what is happening there, and we're talking now about a different waste stream. So we're not talking about the brine. At the moment, we're talking about what's referred to as drilling waste, which includes drilling muds, which are these chemical laden muds which are used in the drilling process in the actual drilling of the well to get the drill bit through the earth and to keep it lubricated. And then we're also talking about what are referred to as drill cuttings, which are just little pieces of earth and crushed rock and dirt that are removed as you drill a hole through the earth. The problem right now is that in a lot of the shales that are being developed, there is an elevated radioactive signature. Black shales can have elevated levels of uranium, thorium, and a number of other heavy metals. So we're again dealing with radioactivity and heavy metals. And if you drill horizontally through black shales, which is what's happening now in the fracking boom, you're going to pull all that material to the surface. So drill cuttings, which are really just crushed bits of rock from deep in the earth, and you wouldn't necessarily think would be problematic. Well, if they're black shale drill cuttings, they absolutely can be problematic. And in Oklahoma, without really analyzing the radioactivity or the metals content, that is exactly what's being applied to pasture land. Day in and day out across the state of Oklahoma and in other states as well, but Oklahoma has really perfected, so to speak, that process. So they would call it fertilizer because they say it's good for crops. I've talked to scientists in Oklahoma and they've conveyed that there's really no scientific evidence to say it's good for crops. You know, one immediate red herring is that farmers are paid to take this waste. Now, if the fertilizer, as they say, were so great, you know, you'd be able to go to like Lowe's and buy it yourself. They're paying the farmers to take it. So that should raise your hackles.
Justin, is this waste making its way into the waste streams that our country is sending out to other countries?
So it's interesting you say that because actually we, as the United States, have such paltry regulations on oil and gas waste. We are actually importing radioactive oil and gas waste from other countries. There is a site in West Texas operated by a company called Lotus, and they have a legitimate permit to take radioactive oil and gas waste. And they some years back asked EPA, hey, we're taking all this radioactive oil and gas waste. We have this appropriate permit for it. And the reason they have this permit is because they sit on top of what's called a salt cavern, which is a big bubble of salt underground. And if you use water, you can dissolve that salt and get really as close as we can on planet Earth to an underground storage locker. Like all things geologic, it's imperfect, but the Department of Energy has deemed salt caverns, once hollowed out, as an appropriate storage locker for radioactive oil and gas waste. Lotus sits on one, so they have this permit, and they ask EPA, can we import radioactive oil and gas waste? Now, that seems completely outlandish, but EPA looked at the exemption I mentioned previously, called the Benson and Bevel Amendments exemption from the late 1970s, and said, yes, this waste is, quote, non-hazardous, so you can bring it into this country. So we're actually taking it in. We're not sending it out.
So everybody who's trucking this stuff around or scooping it up or doing anything with it is being exposed to this radioactivity, and they don't know. But I imagine there must be cancer clusters that are developing around certain sites. Is that the case?
Well, the people who are being most exposed are the industry's own workers. Unfortunately, that's a very difficult group to follow. So, our community is exposed? Absolutely, in multiple ways. But the workers are literally getting smothered and cloaked and plastered in this stuff day in and day out, often working 16-hour shifts, bringing clothing home to their families. So it's literally washed clothes that would be soaked in radioactive waste would be washed in the family washing machine, be stomped across the kitchen floor. And these are legitimate pathways that have been documented going back to the 1980s and 90s in other aspects of the oil field. So we know these pathways are real. And I know from many of my worker sources that these pathways are real because they have these clothes. In some instances, we've been able to get workers' clothing, measure them for radioactivity, and the radioactivity, and in particular, the radium levels are exceptional. Would be far above what would be applicable or allowed at, for example, a Superfund site, these toxic waste sites. EPA has limits for radium. And in one instance, when we were able to obtain a worker's boots, the radium levels in their boots were about 17 times what would be allowed at a Superfund site, which is crazy because here it is, stuck to someone's shins. And we also, by the way, got their hard-hatted headlamp, and there was sludge accreted there too, and that's on their face. And they're breathing it in regularly. So the exposures are very real for the workers. And again, there's a variety of different scientific research articles going back decades that document that in certain sectors of the oil field. What no one has done now is look across fracking country where you have so much more sludge and so much more waste being produced, and thus so much more jobs that have to intimately deal with it. And by the way, these jobs are very, very sloppy, and there's all sorts of corner cutting that my reporting has laid out. So these workers are not being appropriately informed, not being appropriately protected, have intimate contact, and yet no one is tracking what their lives look like in the moment or 5 or 10 years down the line. And that's what you'd really have to do to begin to answer this important question of, is there a cancer cluster of oil and gas workers due to the radiation exposure? There may well be, but no one has looked at that group. And that is exactly what I'm trying to do with some of my reporting and knowledge.
Is anyone working to organize the workers?
There are groups. There's an interesting labor group that has come out recently called Truckers Movement for Justice. They're a trucker organizing group with a very interesting labor focused history. And they have taken this exemption I've mentioned very seriously. And they're really cunning to focus on this. But essentially, if you've labeled toxic radioactive oil field waste as non-hazardous, despite many known hazards, which is what this exemption does, then suddenly these workers who are driving these trucks of waste are being misinformed, right? Because insurance is going to be higher if you're driving truly, quote, hazardous waste. Costs are going to be higher. You're going to get paid more as a driver. You're going to get trained better as a driver. You will receive appropriate protection if it's known that it's, quote, hazardous. And finally, you will actually be better physically protected from the waste because of appropriate PPE, because of appropriate training. And so you will be less at risk and your family will be less at risk. And Truckers Movement for Justice has realized that the people getting most screwed by this exemption are often the workers who are hauling it around in trucks. So yeah, that is an example and an interesting one of how labor has really become alarmed by this and is now trying to organize truckers in oil and gas fields across the country and getting them to recognize these risks and that they're not being paid appropriately for the work that they're doing.
One of the products is the road de-icing, which happens in all parts of the country where there's snow and ice. And apparently it's even put on the streets before a snow. Now, what happens with that stuff? Is that retain its radioactivity? Are our streets, absorbing this stuff? And should we be walking around with Geiger counters to see what's going on? How serious is that?
Yeah, these are great questions, Dale. So this relationship developed in cold parts of the United States, where there's oil and gas. And there's a lot of states that fit that bill: Michigan, Ohio, Pennsylvania, New York. And in many small communities and rural communities, keeping snow and ice off the roads and keeping dust off dirt roads, because rural communities have a lot of dirt roads, that's one of the largest costs of the public works department. So the oil and gas industry coming, as they did, and saying, hey, we've got a fluid that can clean your roads, it can keep the dust down, and it can melt the snow and ice. And by the way, it's free. That really was a major economic incentive. And so many communities across the country over the last century took the oil and gas industry up on this offer, and it became common practice to use oil field waste. And in particular, we're focused on the brine here. So use the brine to melt snow and ice, or try and melt snow and ice, and try and keep dust down. Now, there is some salt, so it may have some success in melting snow and ice, but there's also all these other contaminants. There's heavy metals, there's radium, and there's benzene. Now, in the 1980s and 90s, a variety of states started to push back against this. Ohio and Michigan being primary examples, and they didn't focus on the radium. They didn't even necessarily know that much about it then, but they focused on the benzene. And they really had the medical community look at the benzene, and they were absolutely alarmed that waste with this much benzene was being applied right in front of human beings. And again, benzene is a known human carcinogen. Now, the question of whether there's enough radium to actually track it through the environment, this is something that people are focusing on right now. And there's a great study done with Dan Bain out of University of Pittsburgh and Dr. John Stoltz out of Duquesne University, also in Pittsburgh, and a number of other researchers in that area, where they looked at a prolonged application of radium-rich oil field brine in an urban setting and found that, yes, over time, if you use this stuff over and over again, you're elevating the level of radium, which is a known radioactive metal that causes cancer in humans, and this is not a good thing. And the state of Ohio, in a recent analysis by their Department of Health, has actually also agreed with this. And this is a great example of organizers and activists raising the alarm bell, and the state finally starting to listen in the case of Ohio. But yet, the practice can continue, because even though the state of Ohio has stopped using oil and gas waste on roads that they oversee, products are still available for use in the state, and independent municipalities can make their own decisions to use it. This is the industry's big secret. And when communities have awareness on this, and especially awareness that the workers are most at risk, I think you can start to deconstruct the narrative that the industry uses to overtake communities, which is that this is all for the workers. Well, no. You are contaminating nobody more than the workers. And frankly, nobody is more pissed off when they figure out what's going on than the workers.
Yeah.
And I now have worker contacts who are working with environmentalists to try and convey information. So their entire misinformation campaign falls apart when you truly understand what's in the waste and what they're doing with it.
Well, Justin, this whole problem is just incredible, and I'm so grateful to you for doing the work that you're doing and researching this, because I don't see a lot of attention has been paid to this problem, which has persisted for so long. And thank you for being with us today on Facing Future.
It's an
Justin,
honor.
thank you so much.